Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dogba Jr., mathematics instructor at the University of Liberia and your math tutor. So in my today's video, I will be discussing differential equations. And under differential equations, we will be looking at variable separable method in solving a first order and first degree linear differential equation. So as long as it is first degree, it means it's linear. So I don't have to say linear. Okay, so we discussed in previous lessons how we can solve a differential equation using variable separable under type 1. That is, if you are given a differential equation and if it is possible that you separate the variables. Take, for instance, you have two variables, x and y. If it's possible that you separate all of the expressions with x on one side of the equation, say the left-hand side, and separate all expressions with y, say the right-hand side, it means that that differential equation can be solved using variable separable method by just integrating both sides of the equation. But what if you cannot easily separate the variables? Then you think of how you can bring in some substitution so that after the substitution is done, derivatives are done, then you can be able to apply variable separable method. So that's the case with type 2, which we call reducible to variable separable. So if a differential equation, first order differential equation, seems not to be a separable differential equation, yeah, you can manipulate it. You can do some substitutions, differentiate that new expression or that substituted expression, and then take it back to the problem. So we've solved a lot of problems before, so we want to solve an additional problem or few other problems that we might add to it. So question 36 says dy by dx equals to 1 divided 1 minus y plus 1. So if we carefully look at this, you have 1 minus x minus y. Now let's assume we were to multiply this whole thing by x minus y dx. So in the first area, we're going to get x minus y dy. So it's going to be a kind of difficult thing to just separate all of the expressions with x from the expressions with y. So we could make this to be a single variable. That is, say let u equals x minus y. So if u is equal to x minus y, we know that u now is a new function, and y is also a function in the problem. So x is the independent variable. So if when x is differentiated, we get 1. But when y and u are differentiated, we add the u with respect to the x, and then the y with respect to the variable x as well. So this now becomes du by dx equals to 1 minus dy by dx. So what we need to do now is to find dy by dx, because we are like changing the variable within the original problem. So if we find dy by dx, we're going to get du over dx minus 1. Or let's say we can just send this dy by dx on the left hand side. So you have dy by dx is positive equals, so this is 1 minus du by dx. So this is our dy by dx. So what do we do next? We go back to the original problem and substitute. So in this original problem now, we have dy by dx, which is 1 minus du by dx equals 1 over u, because this is just u, plus 1. So we clearly see that if we simplify this expression, this is a differential equation that we can separate the variables. So we multiply this by u, the LCD. The LCD here is just u and dx, so we can multiply by u dx. So u dx times 1 is u dx. U dx times du dx and dx will go out. You'll be left with u du. U dx times 1 is, now u and u cancel. You'll be left with dx. And then u dx times 1 is just equals to u dx. So now all of the terms with dx, we can group them. And all of the terms with du, we can group them as well. So we have negative du. So this is the only term equals to dx plus u dx minus u dx. So you see, this u dx, they cancel. So this is just minus u du equals to dx. The variables now have been separated. We integrate both sides. Very simple. So this gives us u squared over 2 equals to x plus some arbitrary constant c. So if we can just multiply this whole thing by minus 2, we're going to have u squared equals to minus 2x minus 2c. What is u? U is x plus y. So this is just x minus y all square equals minus 2x. Now this minus 2c. So whether it is minus 2c, it is positive 2c, the fact that it is a constant, if you differentiate a constant, it gives you 0. So even if we were proving that this is actually a solution of this differential equation, it means we will have to differentiate this particular solution. So since you have one constant, it means we differentiate once. So the derivative of 2c will just give us 0. So even if you have whatever constant that is there, whether 3c, 10c, whatever it is, just replace it with a single constant. So we just say let this negative 2c be equals to positive a or positive c or whatever the case might be. So maybe we could say y minus x minus y all squared is equals to a minus 2x. So you want to expand this thing, it's up to you, but you can just leave it as it is. So let's look at another problem quickly. So what if you have dy by dx is equal to some x plus y plus 1 and then divided by x plus y, for example. What if you had this problem and then you were asked to, to solve this problem? So again, we can use similar method because you see x, y, x, x, y. So it'll be difficult for you to easily separate the variables, without the substitution. So now what we can do is to ensure that we say let u equals to x plus y. So if we differentiate du by dx, it's just equal to 1 plus dy by dx. So we see that if we solve for dy by dx, we will have du over dx to be, let's say, minus 1 to be equal to dy by dx. So if we replace dy by dx, it's just du over dx minus 1 equals this x plus y is u, all over x plus y is u. So we can multiply this whole thing by the LCD. 1 times u times dx is just u dx. So dx go into this, dx and dx cancel, you'll be left with u. So it's u du. Dx, 1 going into this is just the same thing. So it's u dx. And then u goes into this, u and u go out, you're left with dx. So this now gives you u plus 1 dx. So all of the terms that has the u, we group them on one side of the equation, and those with the x, we group them on the other side of the equation. So we can factor out the x. So we have u du equals, now if the x comes outside like this, what is left here is just 1, and what is left here is u plus 1. So u and u is just like 2u plus 1 times dx. But this is dx, so we need only x here. So since this is not x, we can divide both sides by 2u plus 1. Divide this side by 2u plus 1. So this we cancel. You'll be left with u du all over 2u plus 1 equals to dx. Variables now have been separated, we integrate both sides to find our general solution. So again, we will say let's use long division. So you can say 2u plus 1 divide, let's say u divided by 2u plus 1. So maybe I can just put 0 because it's from x u to the first power, u to the 0 power. So I just replace it. So 2u into u is just 2. 2 times 2u is, let's say, 2u into this is like saying 2u go into u and u cancel, you left with half. Okay, so it's half times this. So 1 over 2 times this 2u is equal to u. Because like 1 over 2 times 2u is equal to u. And then 1 over 2 times 1 is 1 over 2. We attach negative. And then we will now have this cancel this. So negative times this will give us negative 1 over 2. So now, that's exactly what we're going to have. So this now can be rewritten as the integral of 1 over 2 du, which is this one, plus the integral of, now this is the divisor, 2u plus 1, and then this is the dividend minus 1 over 2 du. Not dividend, okay, this is a new dividend. Or equals to dx, which is just x. So this will just give us 1 over 2u plus, now this becomes minus now, because you have minus 1 over 2. Now, for this 2 ln, that's a 2u plus 1 du all over 2u plus 1. Now, if you say, because the thing is that the integral of dx all over x plus 1 is equal to the ln of x plus 1. But if there is a coefficient right here, assuming that you had a right here, for example, if you say let u be equals to ax, if you differentiate that, you're going to get the u equals to a dx. So definitely it's going to be divided on both sides, right? So this a is going to be like 1 over a. So if this was like ax, it will be ax like this. So it's 1 over a ln of ax plus 1. Similarly, if this is du all over 2u plus 1, then it will be 1 over a. What is a? A is now 2. The ln of 2u plus 1. And then all equals to x plus some arbitrary constant c. So if we multiply now, let me raise this portion. So u, we know u to be x plus y minus. So that portion now can just be 1 over 4 ln of 2x plus y plus 1 equals to x plus c. So if you like, you can send it across. It doesn't matter what the case may be. So if we multiply, you have 1 over 2x plus 1 over 2y equals 1 over 4 ln of 2x plus 2y plus 1, or equals to x, not equal number, plus x plus c. So we can multiply this whole thing by, to get rid of, at least to reduce this. So we can multiply by 2. So this will give us x plus y equals to 1 over 2 ln of 2x plus 2y plus 1 plus 2x plus 2c. So the x now goes across. So therefore we have y to be equals the ln of, now this can be the power of this expression. And since this is 1 over 2, which is half, this becomes a square root. 2x plus 2y plus 1. And then plus, now if this x comes on this side, you will have like 2x minus x, which will now give us x. And then this 2c will just give us a. So this is the general solution of the differential equation. dy by dx is equal to x plus y plus 1 divided by x plus y. So thanks ever so much for watching. Please subscribe to our YouTube channel, like the videos, share them. Thank you, and see you next lecture.